Now, tell me another thing. Can I merge two linked lists in a recursive manner? Let us all learn that, okay? That's quite important. Let us say there is linked list 1. It contains 1, 2, 5, 5, 9, and linked list 2 it contains 3, 4, 10. Yeah, this is really the case, and let's say 15, 25. I have to basically, merge them. So tell me, how can I go about? Let's say there is a function. This function contains the two linked lists. So let's say it contains 1, 2, 5, 5, 9, and it also contains 3, 4, 10, 15, and 25. Now, the basic idea is simple. The basic idea is that head will either be this or this. Effectively, it will be min of these two. Yes or no? It will be, right? So tell me one thing. What I can do is, I can figure out what is minimum in between this and this. If this is the minimum, then I can simply delink this from this 2. Delinking this from this 2 means what? Making this pointer as null. So delink, first part that you can do is delink. And delink what? Delink the min of this and this. Why I am doing that? Because whatever will be the resultant merged linked list of this and this, its head will be min of this and this. So first figure out the min of this and this, and then delink that min with its next pointer. So if you do that, then this 1 will be pointing to null. And after you have done that, then call function on the remaining lists. So when you call function on the remaining lists, first list has got 1 removed from it, so it will be like 2, 5, 5, 9, and second list is as it is. Now, if this is a magical function that somehow returns me the merged answer of this, then that merged answer can be connected with this thing as its head, which can be called as the final link part, and then my job would be done. So, this is again like what is this magical function? This is your recursive function, okay? So when this returns, let's say it has, merged this correctly. So if it has merged both of them correctly, your output would be 2, 3, 4, 5, 5, 9, and then 10, 15, and 25. And if it returns you the head, which is this, then you can connect this head with this in this part, and then you will have the answer for this entire thing. Okay, so this is how it can go on, and your job would be done. So let me take it ahead. Can you tell me what will you do when this function is called? First part would be to delink. Which node will you delink? 2 or 3? You delink 2 because the minimum of 2 and 3 is 2, right? So the merged linked list of this will have this 2 as its head. Even if they are equal, you can choose any and delink, it doesn't really matter. So you can delink this 2 is now pointing to null, and then you can recursively call this function for 5, 5, 9, and 3, 4, 10, 15, 25, and when this is magically done, then you will have the head of this, and you will connect the head of this with this thing. So that would be your final link part. This will keep going. So again, the minimum of them is 3. How long will it go? Let it just go on. So you first delink. So this 3 is now pointing to null, and now you have function of 5, 5, 9, 3, 4, 10, 15, and 25. Let us make our job easy, because I think it will go a lot down. Final part will be to link. I think let's just say that this linked list was till here. So I just have 5 over here. I removed the last 5 and 9. So this is what I'll have. Yeah. Now again, when you are here, the first thing you will do is figure out the min of this and this. Min is 3. So you will delink this 3. 3 is pointing to null. And then you will call f of 5 and this 3, 4, 10, 15 and 25, and final part will be to link. Now again here the min of them is 3, So you will delink this 3, which will now point to null, and then function will be called to 5, yeah, and then 4, 10, 15, 25, and then final thing will be to link. Okay, and now again this will go down where this 4 will be delinked, and you will call for f of 5, 10, 15, 25. Okay, and then final part will be to then link. So I am just trying to go till the termination condition. Now here what will be the minimum of these two? 3 was delinked before. I think there were 2 3s, right? Oh no, there was just 1 3. So I think this got repeated. Okay, forget about that. So but you get the idea, like what is exactly going on over here, right? So in this scenario, let's just focus at this node. In this scenario, what will happen? The minimum of these two is 5. So you will delink this 5 will point to null, and then you will have a function call where first linked list is null and second linked list is like this, and then final thing will be to link. Should this be my termination condition? Yes or no? So the moment one of the linked list becomes null, that must be my termination condition, right? Remember this. The moment any one, whether this or this becomes null, that should act as my termination condition. Does that convince you now? Yes or no? Because it technically makes sense that you are trying to merge two linked lists where one of them is empty and second is non-empty. So if you are trying to merge two linked lists where one of them is empty, what should you return? You should simply return the head of the non-empty. Yes or no? Right? So this is the entire logic over here. So whenever you see that one of these two, either head 1 or head 2 has become null, then whatever is non-null, that you should return. And when you do that, what will it return to its parent will be this 10. And now this 10 can be connected to this 5. So it will be 5, 10, 15, 25. And now if you take a look at this thing has done its job, because now it has merged 5 with this much, and now it will return this thing to its parent, which will now connect that 5 with this 4 and then return 4 to its parent. So this is how things are getting done. From any function call, you are returning the head after merging those two instantaneous linked lists. Okay, and you know what termination condition is, and if you haven't arrived at termination, you figure out your head, you delink that head, and then one linked list will be modified, other will be as it is, and make the function call, and every time return the head. Okay, if I give you k linked lists, I ask you to merge k linked lists. Can you do this thing also? Yes or no? Can you do it using iterative approach? I can do it, right? I can first merge the first. So let's say there are, when I say k linked lists, what do I exactly mean? I basically mean k heads. Yes or no? So I'll give you k heads. So there will be a vector of node star heads, and this vector will have k values in it, and heads of I will be the head of ith linked list. So given those k linked lists, I am supposed to simply merge them up. So easiest approach can be, first you merge the first two linked lists, which is linked list 0, linked list 1, and then you merge the result of that with linked list 2, and then the result of that with linked list 3. Are you getting what I am trying to say? Yes or no? So so let us take that actually. So let's say I had 2, 4, 9, and then 1, 6, and then 3, 7, 11, 12, and then 4, 4. Okay, so what will you do is, you will first merge these two, and then whatever is the result of this, that you will merge with that, and then whatever is the result of this, that you will merge with that. So let us take a generic case. Let us say there are k linked lists, each of size n. So there are k linked lists, each of size n. If I have to merge all of them, all of these k linked lists, what will be the time complexity? K linked lists, each linked list is of size n, and I have to merge all of them. And if I use this technique that I have just told, how much will be the time complexity? Okay, so one of you said k into n, that's a popular wrong solution. Let me make them of equal sizes. So how many of you feel it will be n into k square? Yes, so that is a right series that Guntas has written. So let us do it one by one. First you will merge these two, and both of them are of sizes n and n. How much time will just this much of task take, where you are merging the linked list 0 and linked list 1? It will take 2n time, right? Very good. So it will take 2n time. I am writing it. Okay. Now the result of this, can you tell me the length of result of this? What will be the length of the linked list which is created by merging them? The length of that will be 2n, right? So now you will merge that 2n length linked list with this n length linked list. What will be the time of that part where you are merging 2n with n? It will be 3n, right? So let me write that also. Now you have merged this, this and this. So the length of that is 3n. So now you will merge that 3n with this n. What will be time complexity of that? It will be 4n. Until where will it go? When you reach the kth linked list, it will be k into n. N can be taken common, and this is like sum from 2 till k. To make it simple, you can add a 1 before. It doesn't really matter. Now it is sum of first k natural numbers, which is order of k square. So it will be n into k square. You know why people make mistakes? People make mistakes because they bear it in their head that, hey, the time complexity of merging linked lists is the number of nodes. But no, it depends upon what the lengths are. Every time when you are merging, the length of previous linked list is increasing. Yes or no? And because that length is increasing, so every subsequent step will be costlier than the penultimate step, or will be costlier than the previous step. Can somebody tell me the time complexity of recursive approach of merging two linked lists? Is it order m plus n, or is it greater than m plus n? What do you feel? Let us understand one thing. How many levels will be there? Can somebody tell me the number of levels that will be there? Let me call it out in this way. See, in worst case, what can happen is, okay, can I tell that in every level, number of nodes is being decremented by 1 unit? Can I say that? Because you just extract one node and then all the other nodes are intact. Yes or no? Right? So in every level, the number of nodes is getting decremented by 1 unit. Guys, now when that is being done, in the worst case, what can happen, that your last node, your last level was something like this, where first one became null and second one just had one node in it. It can happen. It can very well happen that your first linked list became null and second just had the last node of it as the head. So in that case, I can say that almost m plus n levels would have got created. So this would be your worst case, where the number of levels will be m plus n. And how much work is being done at each level? D-link is order 1 and linking is also order 1, because I know the head of merging of this and this, and I can just link that with this, and that is also order 1. So in every level, order 1 operations are getting done, and there are m plus n such levels, so the complexity will be order of m plus n. Yeah, so this is the way in which you can comment on the complexity of this approach. Extra space, if you take into consideration the space of recursion stack, it will be order m plus n, because maximum number of recursion stacks that are waiting for each other are m plus n. Can you merge k linked lists, and of course those are sorted? Can you merge k sorted linked lists using recursion? Guys, if you can merge two sorted linked lists using recursion, don't you think you can merge k sorted linked lists also using recursion? You can do that, right? Because let's say these are those k sorted linked lists. If I am just trying to merge these four things, can I say my head will be min of these, right? So that is all. What you are supposed to do is, you are supposed to iterate across the heads of all the k linked lists, figure out the minimum of them, disconnect that minimum, and then call the function where this head will remain as it is, this head will remain as it is, this head will remain as it is, this head will now become this. So it's simple enough that now, so initially you just compared head of two linked lists. Now because you have k linked lists, so you have to compare the head of all those k linked lists, and then whatever is, whatever is the minimum, that you have to delink, and then you have to call for the remaining part, and then when that remaining part is magically, which is recursively merged, you just have to perform this link thing and then return the head to your parent. Okay, cool. So tell me one thing, what will be the termination condition over here? Any head null. Yeah, if any head is null, then you should not stop, right? Because what can happen is that, let's say the 4 linked lists that you are trying to merge are null, 2, 3, 5, null, 1, 9, 7, sorry, 1, 9, 15. Would you want to terminate over here? No, because although these 2 linked lists have already lost their elements because they were merged before, but these 2 are yet to be merged, so you should not stop here. But if the situation is that k minus 1 values are null and just 1 value is non-null, then I can terminate. Yes or no? Yes or no? Does that make sense to everyone? And some of you have typed it also, right? Because if somebody asks you to merge 4 linked lists, out of which 3 are empty, then the head of the non-empty one should be the answer. So all that you have to do is, whenever a function call is made, so whenever now your function call will be made, you will have vector of heads. Because earlier there was just 2 things, now there are k things. So to pass those k things, I need to pass this vector as reference, by reference, right? So first you need to find out that how many nulls are there. If number of nulls are k minus 1, then you can simply return the head of that which is non-null, and that would be your answer. Okay, and then you can terminate then and there. And if this is not the case, then you are supposed to iterate across the heads and figure out which value is minimum, delink that, call for remaining, and then get your job done. Okay.